Look at a perfectly even row of books on a shelf. Your eyes immediately tell you they are all the exact same height. But human vision is an unreliable tool for precise data measurement. To prove this uniformity, we must translate what we intuitively see into a standard mathematical value. We add the individual heights, 50 inches total, and divide by 5 books, giving a value of 10 inches. Doing this in Python is straightforward. We call the mean method on our height column, outputting that exact 10. Because every single item in this dataset is identical, the mathematical mean serves as a highly reliable summary. If you pull any book off the shelf, you know it will be exactly 10 inches tall. Now, let's disrupt the pattern. We place a massive 20-inch art book onto the end of the shelf. In statistics, we call this an outlier. It is an observation that is unusual, a data point that simply doesn't fit the pattern of the surrounding observations. This table shows how our updated data frame looks. We still have our 5 original rows of 10, but now we have a 6th row containing our physical extreme, the 20. We had a perfect measurement of 10 inches. How much does one extreme value alter the profile of the entire dataset? Before we run the calculation, take a second to recall the pandas syntax required to process this new column. Executing the code is the easy part. The real challenge of data analysis is anticipating whether the resulting number accurately reflects the physical reality of the dataset. When we run the updated data frame through our formula, the new average jumps to 11.66. This graphic maps the new average directly back onto our shelf, testing its descriptive accuracy. But look at the gap. The average line hovers completely above our normal books and sits far below our art book. This is the mechanic of skewness. A single unusually high value mathematically drags the entire sum upward. Because we are dividing a much larger total by only 6 items, the average is pulled away from the majority. Trusting the mean on a dataset with outliers gives you a number that is perfectly accurate on paper, but completely misleading about what a typical item actually looks like. Setting the physical books aside, let's review the mechanical rules we've established. This infographic outlines our standard process. On the left, the core math of sum divided by count. On the right, the pandas method to execute it. And directly below, the critical caveat. Always check for outliers before trusting the result. Imagine returning to our original shelf. It's completely empty, except for a single, brand new book manufactured to be exactly 11.66 inches tall. We have a mathematically perfect representation of our calculated mean. Yet it sits in complete isolation. It shares the exact dimensions of absolutely 0 books from our original 6. The mean describes the total aggregate weight of a group distributed evenly. It does not promise to describe the physical reality of any single member within that group. So if an outlier pulls the mathematical average away from the typical observation, how do we locate the true middle of a compromised dataset? We'll write the code for that next.